Hello everyone, welcome to the third part of this PYQ series, and we are solving questions on probability. So continuing the same, let's get started. This question says the security system of an IT office is composed of 10 computers and out of which exactly 4 are working. So we have 4 working computers and then obviously 6 computer will be non-working computer. To check whether the system is functional, the official inspects 4 of the computers picked up at random without replacement. This is important. It is without replacement. The system is deemed functional if at least 3 of the 4 computers are working. Then only the system is deemed functional. We have to find out the probability that the system is deemed functional. So in that case, at least 3 of the 4 computers should work, correct? So what we can do, we can have two cases. In case 1, it can be the case that exactly 3 are working. Exactly. First of all, we have this keyword at least 3. It means what? Either it can be 3 or all 4. So these two cases are there. Exactly 3 are working. Or in the second case, we can have this possibility that all 4 computers are working. All 4 are working. So when we have this case, exactly 3 are working, we know that 4 working computers we are having. So out of 4, we will choose 3 and 6 computers are not working. So we have to choose 1 in that case. And overall, out of 10, we have chosen 4 computers. Similarly, for the second case, what we have is all 4 are working. So 4C4 and no computer is not working. So 6C0 and out of 10, we are choosing 4. So these are the two possible cases. And we know that we have to apply addition rule here because either of the case can happen. So we write down the required probability to be equals to 4C3 times 6C1 over 10C4 plus the second case 4C4 times 6C0 over 10C4. Simplifying this, we are getting this as 24 and 10C4 is 210. Here also 4C4 is 1, so we get 1 over 210. Adding both of them, we get 25 over 210, which gives approximately 0.119. And in the question, so this is the required probability. But if you see the question, the probability is given to be already P. So we can write P as 0.119. So this will imply the value of 100 times P. It is going to be 11.9. Hope you understood the concept. Now, let's move to the next question. In this question, we have been given that we have to find the probability that a given integer lying between 1 and 100 is not divisible by 2, 3 or 5. So here we have 3 cases. What we have to do is we have to apply something which is called as the inclusion-exclusion principle. Inclusion-exclusion principle says what? Probability of A union B union C. For 3 sets, we are writing it is nothing but probability of A plus B plus C minus the intersections. So A intersection B, B intersection C, and A intersection C. And then we add the intersection of all of 3. So this is the inclusion-exclusion principle. So if we apply this, let us take A as divisible by 3, divisible by 2, sorry. Similarly, event V, we can describe it as divisible by 3, and event C is described by 5. So in the question, first we will find what is the probability that it is divisible by at least one of them. So you applying the same rule, What is the probability that it is divisible by 2? Probability that it is divisible by 2. We can calculate it separately here first, then we will apply. Correct. So I'll give you just a rough idea of how to calculate this. So probability that it is divisible by 2. So total how many numbers we have? 100. So we use to count this, we use floor function, and 100 is a total numbers and divisible by 2. So if we calculate this value, this comes out to be 50. This floor function, we know it is always gives a less than integer value. Then probability that it is divisible by 3, what we will do is, again, the floor of 3, 100 over 3. So we get this as 33.3. But floor function also gives an integer output less than this value. So we are getting that 33. Similarly, probability that it is divisible by 5. So to find that number, we take this floor of 100 over 5 and exactly 20 we will get here. When we talk about probability that it is divisible by 2 as well as 3. So what we do is, in this case, we take the floor and in the denominator, we take the LCM of 2 and 3. So here what we will get is 100 divided by LCM, which is 6. Correct. Simplifying this, we'll get 16 only. Only integer we have to consider because that is the output of the floor function. So if we have two numbers, we take the LCM. Similarly, we can get probability that it is divisible by 3 and 5. So what we do is 100 divided by the LCM of 3 and 5, which is going to be 15. And in that case, this comes out to be 10. And finally, what is the probability that it is divisible by 2 and 5? So LCM is again 10. And if we do 100 divided by 10, we get exactly. And at the end, we can also calculate the probability that it is divisible by 2, 3, and 5. All three intersection we are considering here. So LCM of 2, 3, and 5 is 30. So we can write this as 100 over 30, which gives the value as 3. Correct. So from this, just substitute these values into this. What we get that probability that it is divisible by at least 2, 3, or 5, any of them, it is going to be probability of A plus B plus C minus 16 minus 10 minus 3. Sorry, minus 16 minus 10, again minus 10 we are having. And then we will add this 3. Correct. Here it is 6, that correction kindly correct it. So this is 6. So minus 10 minus 6 plus 3. And divided by, so these are the favorable outcomes, and divided by the total number, which is 100. Simplifying this, what we are getting is 74 over 100, which gives the answer as 0.74. So this is at least case, but we have to find that it should not be divisible by any. So from this, what we will do, probability that it is not divisible by 2, 3, or 5, it will be nothing but 1 minus this case, the at least case. So 1 minus 0.74, which gives the required answer as 0.26. Hope you understood this question. Now let's move to the next one. So this is our next question. It is given that S is a sample space and two mutually exhaustive events have been given. Exhaustive means what? Their union has to be empty. Sorry, their union has to give the whole of the sample space. Correct. So in this case, what we are going to do now? We can apply AMGM inequality for it. From this, what we can say, we know this inequality, right? AM is greater or equals to ZM of two numbers if we take A plus B over 2 is the AM of two number and GM is just square root of the product. So here what we can write, probability of A plus probability of B over 2 will be greater or equal to probability of A times probability of B. But we know that probability of A plus probability of B, it will be equals to probability of the sample space, which is 1. From here we can see they are mutually exclusive. So we can write down the root of probability of A probability of B will be less than 1 over 2, which will implies that probability times of A times probability of B will be less than or equals to 1 over 4. From this, we get the maximum value of probability of A times probability of B equals to 1 over